Good morning, student. Myself, Dr. Kapil Kumar Sharma, presenting a lecture number 5 that are quantum mechanics. These are the last lecture in your syllabus. Here, the content of this presentation, like we will discuss Compton effect, direction of recoil electron, and kinetic energy of the electron. Where you see the structure of the diagram. Here, there are two diagrams available in this presentation. In 1892 to 1962, he have a great research in quantum mechanics. As per we are moving classical to quantum mechanics. As per classical mechanics, energy is always in this continuous manner. So in quantum mechanics, we will deal the energy is always in discrete manner. Here we see the what is quantum effect. As per quantum mechanics, the Compton effect, it can be possible change in frequency. So, as per sentence, change in frequency after scattering is called Compton effect. First of all, we develop a diagram for a very short wavelength. If X-ray, we have a wavelength is very short as compared to the other light that are 0.1 to 10 angstrom. These are collimating light. These are wavelength. Then strike on the target, the frequency lambda dash will be changed, and these changes can be detected by this detector. Here, these are the changes. These are incident photon. The frequency is h nu and hit the target and recoil electron, and these are the scatter photon. The scatter photon will have change the frequency. This change in frequency in term of calculation like h upon m naught c 1 minus ka cos theta. These are very important aspect for calculation. So we deal this calculation by this formulation. According to the quantum mechanics of theory, radiation have two frequencies. The original unmodified frequency nu and modified frequency nu dash. As per see in last figure, the original unmodified frequency nu and obtain the scatter frequency nu dash, we have changes. That is changes is always known as scattering of the incident photon with free electron of the atom. These frequency nu and nu dash or wavelength lambda and lambda dash are observed simultaneously. These frequency nu and nu dash or wavelength lambda and lambda dash are observed simultaneously. It is observed that difference between modified and unmodified frequency delta nu, nu minus nu dash, or we can also in term of wavelength lambda dash minus lambda. They increase the value, the angle of scattering of incident, but it is independent of the frequency of incident radiation. This is also Compton effect. Here, let we assume an X-ray photon of frequency nu and moving along the x-axis collide with the free electron as per C in figure first slide. O. The Cartesian coordinate of system in this figure 1. Here the sum part of the energy we calculate the utilization of recoil electron and etc. The rest of the out of the from scatter photon of energy h nu at angle theta let as rest mass of the electron, that is m naught. Here from the concept of variation of mass, m is equal to m naught upon 1 minus v square c square. These are studied in unit 1, that are rest mass of the particle, and v is the velocity of the particle, c is the velocity of light. These are improper mass. They are studied in relativity mechanics. Here we apply the conservation of energy h nu plus m naught c square plus h nu dash plus mc square. We solve the equation, and again the apply of conservation of momentum h nu upon c, this part, plus 0 because it is the rest mass of the free electron, and h nu dash by c, these are the theta angle, and mv cos phi, they are recoil electron. We solve the equation number 3 and apply the conservation of energy along the y-axis. First week along the x-axis and along the y-axis. These are 0 y-axis because 0 momentum, and these are 0 plus h nu upon dash upon c sine theta, and minus sign will be for opposite direction. They are particular opposite direction. And solve the equation number 4. Square and add for 3 equation, and equation become like this. Thoroughly we solve the mathematical equation and represent m naught square c power 4 plus 2m square mc square h into nu minus nu dash plus h square to nu minus nu dash cos theta minus 1. These are solving this mathematical expression. We solve the equation 1 upon nu dash minus 1 upon lambda is equal to h upon m naught c square 1 minus cos theta. Because we know that nu is equal to c by lambda. These are the relation between energy. These are the relation between particle frequency and wavelength. And in term of wavelength, these expression are coming from this solution lambda dash minus lambda is equal to h upon m naught c 1 minus cos theta. These equation represent the Compton shift. If we have theta value and c is constant, m naught is constant, h is constant, we put the value. We can say that the Compton shift is only depend on the angle of scattering. Here, equation number 7 represent the Compton shift, that is lambda minus lambda dash. If we put the value, if theta is equal to 0, we put the value because cos 0 is 1 and that will be 0. If maximum value, that h upon m naught c, then that is Compton effect. Here, if the incident photon is interacting with the electron of inner shell, like bound of the electron, m is recoil electron instead the mass of the electron. You can also, by this equation, these are the reduced mass of the hydrogen atom. We have 1836 of m naught. These are standard constant as you study in 10 plus 2. Delta lambda 0.0242 upon this value. If we have a 3 case for different angle, if theta is equal to 0, then frequency is no change. If theta 90, that is lambda c, the critical frequency, and 180, these are the critical frequency. These are the parameter for calculation. Another, we also calculate on the basis of this experiment like a direction of recoil electron. If we divide the equation 3 and 4, the equation become this value, and we know that these are the formula and lambda dash to put the value and get the result. These are result become 10 phi is a direction of recoil electron because after scattering, some electron will eject from the shell. Then nu upon 1 plus this value, and putting this value, an equation become 10 phi is equal to cot theta by 2 plus 2 h nu upon m naught c square. These are initial before condition, these are after condition. These are energy h nu, these are energy h nu dash or f dash. We can different type of coordinators. These are initial energy, electron, and these are kinetic energy expression. Now we again calculate the kinetic energy expression for this limit. Again, we know that h nu minus h nu dash, h nu like this value, equation number 12, and equation become by solving equation h square nu square m naught square 1 minus cos theta upon 1 plus h nu upon m naught c square 1 minus cos theta. Here we different case, like if theta is equal to 0, then kinetic energy will be 0 because there is no transition. Minimum energy transferred to the electron by the incident photon is 0. Case 2, if theta 90, then we put the value. If theta 180, then maximum value, maximum energy shifting is 180. Photon is transferred to the electron, thus we can say that photon X-ray are unable to express the whole energy of the electron. Importance of the Compton effect. Like it is gives direct proof of the validation. What is the outcome of this experiment? These are very important experiment, like validity of relativistic formula. We can say that mass can also vary by this formula. Correctness of the energy and momentum expression of the radiation energy, the law of conservation of energy. These are important parameter can be expressed in this equation. These Compton effect outcome, these are intensity parameter. If theta 0, there is no shift. If theta 90, these are the shifting. These are shifting. Again, these are 45 degree, these are 135 degree. We have changed. If we see the diagram 0 to 135, they have separation for this value. Again, we can understand the wave nature of the particle. The last slide, we can represent the limitation of this theory. The theory justifies the presence of X-rays longer wavelength. and scatter beam, but give no expression of the presence of this shorter wavelength. To unmodify radiation frequency h nu and nu dash, the collision between the photon and bound electron, since electrons are bound to the atom due to electrostatic force of attraction, we know that the certain amount of energy is required to detach an electron from the atom. It is obvious from the Compton effect of the quantization, not visible light. If we use 4000 to 7000 angstrom cannot be used for demonstration because Compton effect, because it is corresponding principal energy 2 to 3 volt, that is lesser to the binding energy, because electron cannot hit the amount of energy for this energy. Here you cannot use the ultraviolet light of 10 electron volt because cannot see this effect. The valence electron shall be the hydrogen like atom, it treated as a electron gamma rays. So conclusion of this, Compton effect is not observed for visible light. It is only work for shorter wavelength or gamma rays. Thank you very much. These are presentation. In our classes, we will discuss some important numerical for this parameter.